Hello all, hope you guys are doing well. Uh, Hello all, hope you guys are doing well. Only four. Okay. I hope you have gone through last day's discussions and have understood the points of data cleaning and data processing and all that. Today we will be doing the fun part of entire data science project, that is building a model, training it, and see how good our model is performing, right? So let's just wait for 2 minutes. 6 has already joined. Few more people. Is there any doubt you have in your mind regarding last 2 days session? And most importantly, my audio and your video, is it clear? Can you hear me? Maybe a few responses would be good. Okay, I'm expecting others to join soon. It's 6:33. Okay, so without any delay, let's start. Maybe other people will join soon. Till then, let's just start our today's session. Okay, so today's session we will be doing the building the model part, right? So if you remember from our first class, there are two types of problem we deal in our current in any given problem. One is with continuous data points, and other is categorical data points. Okay, so numerical and categorical. Okay, so let me just switch on my digital notebook and switch over there. So yeah, so just give me a moment. Yeah, so we have two kinds of problem. One is continuous data, problems, and another is discrete data problems. Okay, so continuous example of continuous data problem can be prediction of age of a person. Okay, and discrete data problem can be prediction of gender, right? So if I want to predict whether a given person with lots of feature, whether he is male or female, that comes under discrete data. Okay, the target, if the target has distinct variables, then it is called discrete data, and such kind of problem is known as classification. This kind of problem is known as classification. Okay, and if we need to predict a number like the age can be 5, it can be 6, it can be 10, 50, 65.5, it can be anything. If we are to predict a number, then this kind of problem, that is continuous data, that can have any value. Continuous means it can have any possible values, numerical values. This kind of problem is known as regression, right? So this we already discussed. So now we will see some machine learning algorithms to deal with these two kind of data. Okay, now data can also be of two types. One is labeled data, one is unlabeled data. Okay, so labeled data means, let me give you an example. Let's say our data looks like this, something like this. It says height, it says weight, it says let's say height, weight, and it says let's say waist. What is the waist? It says maybe let's say the other features. Let's say these three are the features, and then the category we want to find is gender, right? So let's say this is our data, okay. So if the given data, what data we will be using in our algorithm, if the given data has some features, so these three are my features, right? These three are my features. Okay, and this one here, this is my label, or sometimes it also called as target. Okay, now if in a given data this column exists, if this column exists, then the data is called labeled data. Okay, and if this column does not exist, this is called unlabeled data. And depending on which kind of data we are using in our algorithm, the algorithm can be classified into two categories. One is, you know it, supervised and unsupervised, right? So supervised means we have the labeled data, unsupervised means we don't have the labeled data. So today the algorithms we will be talking in our lecture, we will be dealing with supervised algorithms, where our target data is available at the time of training. Okay, so now that being said, we know what is data, what are the differences between label and unlabeled data. Let's just talk about the models we will be learning. So there are n number of models. Okay, there are separate models. Now in this class we will be dealing with three basic models. Okay, so first model we will be looking at, that is linear regression. The second model we will be dealing with logistic regression. Third model we will be dealing with k nearest neighbor, or in short it is also known as KNN. Okay, so these are the three models. We will see a bit of theory background and then we will code live and see how this model can be built and applied on a data. Okay, so without any further delay, so let's start. So our first model is linear regression. Okay, so this is our model 1. This is our first algorithm, not model, algorithm. Okay, before going further, let me just check up on how many guys already joined. Okay, still there are a few people who not joined. Anyways, we won't wait any further. Let's do this. Okay, so a brief introduction about linear regression. What is linear regression? Linear regression deals with the continuous data, right? As the name suggests, regression, that means we have to predict a numerical value. Okay, this regression term is coined by Francis Galton back in 18th century. So the concept of regression is age old. Now we use that concept in our machine learning to train our data. So what is regression? Regression, actually, if I take the term itself, it's drifting towards. Okay, drifting towards. So what Francis did, Francis took the father side and he tried to predict the son side. That was his experimental setup. He took a sample of father height and he tried to predict the son side. So it is likely if the father is tall enough, his son will also be tall enough, or his son's height also try to mimic or drift towards the father side. But after his study, after his experiment, he found a very interesting thing. Although the son's height tries to drift towards the father height, but it more drift towards to the general or average height of a man. Okay, so not necessarily if the father is too long, let's say someone is 7 feet, the son will be also 7 feet or something. If the general height or the average height of a man is 6.5 and a father's height will be 7 feet, though the son's height is likely to be between 6.5 and 7. So it tries to drift towards the father's height and maintaining to remain close to the average height also. This is the regression analysis he done. Now this is a brief introduction of how regression works. Now we will be taking up some mathematical explanation, a brief mathematical explanation about the regression. Okay, so now you have understood what regression actually does. Let's take how to know if, let's say I have a sample of father side and a son side. How we will know if my model is predicting some height of a son, it is actually the height of the son, right? So we have certain data. Let's say we have 200 data points of fathers and sons. So what we do, we take, let's say 150 samples out of 200 and feed it to the ML model. The ML model learns, like, if the father height is 5, the son's height will be 5.2. In other case, if the father's height is 5.1, the son's height is 4.9. If the father's height is 6.2, the son's height is 5.8. Likewise. So there are 150 samples which is fed into machine learning model, and we also fed the linear regression algorithm into the model. Now I am not talking about more of linear regression, how the mathematical background of linear regression, how it works. If you want to study the statistical background of linear regression, I would suggest you you go to introduction, I refer you to the book Introduction to Statistical Learning. Okay, this is a book, this is a very good book by Gareth James. Okay, you go to the chapter 2 and 3 and you can see the mathematical background of linear regression. Okay, so once we are done with the training of the model has trained, then what we will do, we will just apply the other 50 data. The other 50 data we already know. This other 50 data we already know, but we will apply only father's height, and we see how the model is saying the son's height should be. Then we have the son's height in our actual data, and we have our predicted value. So the model will give some prediction, and we have the actual value. So let's put it in a mathematical situation. So let's take actual is equals to y and predicted is equals to y cap. Okay, for ith sample. So for, let's say, for 51 sample or 52 sample, so this is the ith sample. So what could be the measurement we can take to find out whether our prediction is good enough or not? Okay, so in case of regression, we have 3 actual measurement, that is MAE, MSE, RMSE. You may heard of about those things, that is mean average error, mean squared error, and root mean squared error. So mean average error is what? We take the predicted value and actual value, and we find out the difference, and we take the mod. Okay, so there is no negative sign. You can interchange prediction and actual, it won't matter, because we are taking the mod. And we take for all the i's and we sum it up. For all the i's, for all the values, for I equals to 0 to n, let's say we have n samples, test samples, and then we divide it by the number of samples. So we take the average. So that is our MAE. Okay, so this is our MAE. So in case of MAE, we do this. For MSE, that is mean squared error, what we do in mean squared error, we do nothing. The actual equation remains same. We take the difference of the actual and predicted output, but we take the square terms in case of MSE. So actually what it does, if the difference is large between the actual and predicted, the model actually will be punished more. Okay, if we take the square, the difference will get higher, and if the difference is low and we square it, it will become lower. So if for a good prediction, the model will be the MSE will be low. For a bad prediction, the MSE will be high. So it gives more accurate result in terms of evaluation. But there is a one problem. If we take the square, actually the MSE we are measuring for the unit, it will also be square. Like here we are measuring age, right? This is the target variable. We are predicting age. So if we take MSE, the output prediction will be age squared, because we are taking square here. To minimize this thing, and this unit squared sometimes can lead to some other interpretation, like if it is let's say meter, the distance. If I take the meter square, it can be interpreted as a what do you say, meter square is the area, right? So whether we are taking the measurement of the distance or the area, it can get confused. Okay, so to minimize this error, or to take account into this error, RMSE is developed. So what is RMSE? RMSE is just the square of MSE. So we take the square root, sorry, not square root, and find the root mean square error. Okay, so this way we can deal with the squared unit factor. We can get rid of that squared unit. Okay, so now with this much of introduction of what we say, the evaluation matrices and regression, let's jump into the code and see how it works. Okay, so for this till now we have used three libraries, right? What libraries we have used? Pandas, NumPy. We didn't use much of NumPy. Maybe in coming time we will be using it, but still NumPy we have taken into account. Matplotlib. These are the three major parts. Now we will be using sklearn. So these are the four major pillars of machine learning algorithms. Of course there are others, but if you can get a hands on these four packages of Python, you can deal with majority of machine learning algorithm. Not deep learning, I am repeating, machine learning algorithm. For deep learning you may need something else too. Okay, like Keras, TensorFlow. For natural language processing it will be NLTK, like that. Okay, so don't we won't discuss it here. We will be dealing with scikit-learn in today's class. Okay, so most of the packages, most of the algorithms are pre-written in sklearn, so we don't have to write any code building the algorithm itself. We will be dealing with the data like we did before. Then we will be seeing how to use that pre-built model on our data and how to evaluate the model. Okay, so without any further delay, let's jump into the coding thing. I will be let's just hide myself so that you can see the entire Jupyter notebook. Okay, so let me see if it is showing right. Okay, cool. So let's just open up a new Python. Okay, now I have taken several datas we will be discussing in today's, hopefully in today's entire course. So you just stick with me. We will be I will share all the Jupyter notebook and data after this class, and I will expect you to do some exercise also. So I will share that notebook and data sources also. You can do that exercise and submit it back to me. Okay, so we will take care how you will get that. Either I will share my drive, or you will get an email with the data and all the stuff, the resources. Okay, so any further delay, let's just do our first thing, that is our, let me just that is our linear regression. Okay, so first what we need to do, import of libraries, pandas, import let's just take pandas as np, pd, import numpy as np, import matplotlib dot pyplot as plt, and import seaborn as SNS. Okay, so the import of I must be misspelled matplotlib. Okay, cool. So first what we need the data. Okay, so I have housing data, and that is a famous data for regression, so we will use that only. So we can do it, df is equals to, how we read data, using pandas library, pd dot read CSV. So if you press tab on Jupyter Notebook, so it will give you the entire syntaxes. Okay, so if you don't know the syntax, you can just do that, read CSV, and if you press shift tab in Jupyter Notebook, after writing some syntax, it will give you what are the input arguments you can pass in that syntax. Okay, so here I have pressed shift tab, so it is giving me a very brief introduction. If you want to see more, you can just press the star plus sign, and it will give you all the syntaxes you can pass, okay, and the details of it, right? So you can check. This is a very good feature of Jupyter Notebook. So let's just pass our data, that is our, this is our data. Let me show you, USA housing.csv. Okay, so we will just copy it and paste it here, right? So we have the data. Let's just see the data head. So this is our data, these are the features. Okay, these are the features, and we are here to predict the price of the data, giving the average area, income, and all this stuff. Okay, so let's just see what are the information we have about the data. To see that, we will try df.info. So these are the things. These are floats, all other number are floats, and there is one object, that is address. So we can check the object as well, that is type, what object it is, df, and pass on the column name, that is so it says it is a pandas series. And if you want to know what kind of in series, what is the type of data, we just take an element of the data and see the type, that is a string. So now we know everything about the data, at least the overview. How many data points are there? 5,000, right? So 5,000 data points we have. Using that, we will be doing our linear regression. Okay, so let's just do some exploratory data analysis, that is, let's see the pair plot, SNS dot pair plot df. It takes some time, So the pair plot gives you an idea how every variables are related to every other variable. So it is 1:1 plot of the given. Okay, let me just zoom out a bit. If you can see, these are the columns, okay, in x-axis and y-axis. So whichever column is, this is price versus price, gives you the histogram only, and the price versus other columns gives you the distribution of relation of price with respect to the other columns. Okay, so if I just zoom in and give you the last, so you can see here, this is the average area income and this is the price. What is the relation between price and average area income? So if you have a less amount of data, you can always plot and see how they are related. Okay, if you have a huge amount of data, you can also then also you can do that, but it will take more time, okay, because it takes account to every data and plot it against every other data, so it may take some time. Now let's just see the target variable, that is our price, how the price is distributed, right? So to do that, SNS dot dist plot, that is for distribution, and what we want to see, we want to see the price column, so we will call df price. Okay, so let's run it. Why it is showing error? Let me just see. Okay, P is in capital. So this is a fairly normally distributed curve. Okay, so this is the price. Okay, so 1 into 10 to the power 6, and this is the number of the house. This is the count of the number of prices that has this many price value. So the majority of the house price between 1 into 10 to the power 6 and 1.5 10 to the power 6. Okay, this is the meaning of this distribution. Okay, so now let's see the heat map. So I'm just repeating all the steps we have done in data analysis so that you can get a df dot the correlation heat map. How the now here we have seen the scatter plot, now we will see the correlation and the heat map of the correlation. And if I just do that, there is so many df. So if you see here, this is the correlation. Now the less correlated values are in the dark shades, and the high correlated values are in the lighter shades. Okay, so if I want to see the correlation value also, what we need to do, we just pass in another argument, that is annote, that stands for annotation equals to true. It will annote all the values. So now we can see what is the correlation coefficient between any two variables. So if I want to see price versus let's say area number of bedrooms, so it is 0.17. the correlation value is 0.17, right? Okay, so now we got an idea how the values are related. Let's just take df dot columns. What are the columns we have? These are the columns, right? So we want to have a training data. Okay, we want to have a training data where we will have the features, right? The features are everything but the price. Okay, so we won't include price as feature. We will use price as our target variable. So let's take x as our features. X is equals to, so there are two ways to do it. you can call every other uh, column by name. Okay, so X will be that, or you can do what else you can do. You can do df dot drop the column name, the column you want to drop, price, and you said in place, in place equals to true. Okay, and you need to also you need to mention the axis also. Axis equals to 1. Okay, so these are the two ways. This is fairly straightforward. You copy and paste, or you type in all the columns you want to be in your feature set, or you just drop the target feature set. This is more convincing because you may have thousands of features in your real life data set. Okay, so typing in all the column names can be hectic, and it is a poor way to do that. So you just drop the target column, and to mention it as a column you need to pass axis as 1. So axis is the if 0 is passed, it is an x-axis. If 1 is passed, it is a y-axis. So y-axis means it will look by column, and in place equal to true. That means this performance, the dropping of price, will be constant, will be there, continued. If you don't use in place equals to true, it will just use that as a temporary syntax. Okay, what happened? Okay, so why this error is showing? This error is showing because we already dropped it. Okay, so let's just do for the let me just import it once again, because we okay, right. So now we have X. Okay, it is running. Okay, so the pair plot takes a time, so the other things are pending. Okay, price, heat map, columns, and X. Now what is Y? Y is just our price column. Okay, so now we are done with creating our feature and levels. So you see, when we need to call more than one number of columns, we pass it in a third bracket. That is because we pass it as a list of columns. But if I want to pass only single column, we don't need a list, we need a single element. So we don't have a list here. Sorry, so we have X and Y as our training and testing. Let's call the scikit-learn. Okay, so what we need from scikit-learn? So from sklearn, dot model selection, import train test split. Okay, if I run this, so what is this? sklearn is a library, and we have a module in the library is name model selection, and under that we have a function called train test split. Okay, so what we will do, we will use this train test split to split our X and Y. Why we need to split our X and Y? This the splitted part will be using, first part we will be using as training, and the second part we will be using as testing. Okay, so there will be 4 parts, because 2 part from X and 2 part from Y. Okay, so how we will write it? You can give any name, but let's just go by this X train. So this is for training, and X test, this is for testing, then Y train and Y test. Okay, so first it will split the X. So X will be split in X train, X test, and then Y is Y train, Y test. That will be equals to, we will call the function train test split, and we pass these two inputs as X and Y. So X comma Y. Okay, and now few more arguments we will be passing. So what is this? Test size. Let's just pass test size. So let's see what are the arguments. Okay, so it is showing test size is equals to, let's say 0.4. Okay, let me just write it down, then I will explain it what these things mean. Random state is equals to, let's take 101. Now what is doing we are doing here, we are splitting X and Y, and we are mentioning that the test size or the way it will be splitted is 40% of the split will be go to test. So X test will be 40% of the X and Y test will be 40% of the Y. And random state means if you don't mention random state, then also it will run, but random state helps us in a way that it will split in a particular random fashion. So it will take random 60, if it is 100 samples, it will take random 60 samples for training, random 40 samples for testing. But no matter how many times you run it, if you mention random state, it will take the same 60% of from training and same testing 40%. So the randomness will remain constant if you mention a state here. But and this doesn't matter 101 or something, any number you can pass on here. So the pattern of randomness is this code 101 or 1 2 3 4. You can pass anything from 0 to whatever you want. Okay, but mentioning it helps you to understand the thing, because if you run it more number of times, the different train test split will happen, and you cannot judge whether your training algorithm is performing on the same data, and there will be a problem of evaluation. Okay, so let's just run it. It is done. Okay, now once we have our X train, X test, Y train, Y test, you can see it here also. X train dot shape, if you run it, you see there is 3000, that is the 60% of our total data, right? And we have 7 columns in our X. And if you see df dot shape, it has 5000 columns. Oh, you see the number of columns are same here, because I forgot to delete this. So let's just run from here again. Y test. Now we are good. We have X train as the 6 features, and Y as, and let's also take Y we do need to check. Okay, so we are done with splitting. Now let's do the training. So for training, we will call the algorithm itself. So sklearn dot, now we will call another module called linear model. So it is linear model, and we will import from that we will import linear regression. Okay, so let's just import it. So it is imported. Now we will create a instance of linear regression. Just a second, let me just okay. So linear model, or you can call it anything, regression, regression model, or I can just call it LR. Okay, so LR would be representing the linear regression model. Okay, so LR will be the instance of the linear regression function that we just called. Okay, so it is more than a function. It is just it's the algorithm we called from this module. Okay, so we create an instance. Okay, now what we will do, we will just, I have an instance of the algorithm. Now I will fit this algorithm into our training data. Okay, so we will pass this algorithm and fit our data into this algorithm. How we do that? Using LR, that is the model instance, dot fit, and we pass the training samples. What are our training samples? X train, that is our feature, and Y train, that is our level for those features. Okay, so X train, Y train, if I just pass it, we could not convert string. Okay, so what happened here, the value error is saying we could not convert string to float, and this is the string, it couldn't convert it, it failed to convert. Okay, so what is this? This is actually showing we imported the entire columns, all the columns but price, apart from price, as our features. But as if you remember that our model, any model in machine learning, cannot handle the string input. Okay, so either we need to convert these addresses into something numerical, or we can just drop that address. So before that, let's just see what is the relation between the okay, you cannot also see in the plot. Okay, so we need to convert it into our numerical thing, or any numerical representation of address. But address doesn't play any major role, so for the time being we can always check how to represent this address. Okay, by exploration, how many unique addresses are there, how to represent those addresses in our data. But I am not doing that in this lecture because it will take more time and we need to cover 2 more algorithms. So for the time being, I'm just dropping this address column, okay, in our training. What is this? Okay, so our X won't have this column also. So let's just rerun this again. Now what happened? Okay, I didn't run it. Let's just run it. Okay, so the output shows the linear regression is being fitted to our X train and Y train. Clear? So we encountered some problems. From that problem we can see what kind of error we saw. The value error says the value have in that particular column or element the algorithm try to process cannot process because it is a string. It cannot convert the string to the float by itself, so you need to convert it. So we just deleted the column for the time being, but you can always do exploratory research how to represent that into numerical form. Okay, so now as we have our model fitted, let's just do the let's just see the model. Okay, so let's just print LR intercept underscore. Intercept underscore. What is happening with my typing? LR dot intercept. Okay, so what this means, it means the value of the intercept, LR intercept. Okay, so if you go through the linear regression theory, you will understand what is an intercept and what is the coefficient of the algorithms. Okay, so I am just displaying the value of the interception and the coefficient. So the coefficient you can see, so let's just coefficient can be written as, so let's just have it in a data frame LR dot coef underscore and X columns and the column name would be, let's just give the name coefficient. And if I just run that, so these are the coefficients. Okay, let me just explain what just happened here. The coefficient of this algorithm, the regression coefficients, the linear regression should have a straight line, because that is linear, it will have a straight line, and if there is a line, there is a equation of that line. Okay, so what will be the equation? Equation will be the variable multiplied by some coefficient, like y equals to ax plus b, right? So a is the coefficient, x is the column or the feature, and b is another coefficient, that is a constant. Okay, so these are the column for x, these are my x, or we can say y equals to ax1 plus bx2 plus cx3 plus d. Okay, so these are the x1, x2, x3, x4, and these are the a, b, c, d's. Okay, these are the coefficients of that column. So how to call that? LR, that is our model dot coef underscore, and I want to see the columns, and the name of the columns will come under the column name coefficient. So this is our column name. So this is how we wanted these are x dot columns are our indexes, and the values of our column will be named as coefficient column. Okay, so this is how we can see the coefficients. Right now, the model has done its training. Now the prediction part begins. So how do we predict our test data? So the model has learned something. Let's see how good or what it has learned, or how good its learning is. Okay, so to do that, let's just just take a variable predict, and to see, it is very straightforward. Predict, the model dot predict and we pass the test set. So now we have the test result in our spread, this spread variable. Okay, so now let's plot the variable. How do we plot that? Let's take plt dot scatter, that is a scatter plot, and what we will have in our scatter plot, the actual variable, the actual value of the data and the predicted value of the data, and now we will see how linearly it is plotting. If it is a linear relation between the actual and the prediction, then we can say we have developed a good algorithm. So let's see. So we have the actual value as y test, because the actual value of x test is splitted and put it into y test, and now we have the result of the model, that is spread. If I just plot it, so this is the plot, this is our actual value, this is our predicted value. Yeah, and you can see it is pretty much linear. So the relation between the actual value and prediction value is linearly, the values are linearly related to each other, right? You can do another distribution plot also. So sns dot dist plot to see the distribution. Okay, so once we see the distribution, I can explain you what this means. Test det and y test and prediction, and we call bins, let's say bins equals to 50, and just run it. So what is happening here, the y test is in the y test and predictions are being distributed over single figure window. Okay, so y test are the distribution plots, these are the bar plots are y test, and this curvature plot is the prediction test, the predictions, and the curve shows what is the predicted price for what is the number of predictions for the price. Okay, so this is the mean value, don't worry about 0 and minus and plus, this is the mean. This is how these are the standard deviation and all that. So don't just worry, just see and try to see what are the pattern of the bar plots here, which is y test pattern, and what is the pattern of prediction plot, and whether these two are colliding or not in the same pattern. So as we can see from here, it is pretty much following, the prediction is pretty much following the y test pattern. Okay, here some errors are there, but still we can say it is a very good prediction, or acceptable prediction, if I may say so. Okay, so now once we have the pattern, let's take the evaluation matrices into account. So for that we just need to import matrix sklearn import matrices. Okay, so now we want to see what are the mean average error, mean squared error, and root mean square error. Okay, so let's do that. So let's print, let's say mean average error will be, what will be our mean average error is our, we call the module matrix dot we can just tab it, my system is slow, let me just write mean absolute error, and then we will just pass arguments of our actual and predicted value. So y test is our actual and spread is our value, right? So we have, sorry, so let's see. So this is our MAE. So what is this MAE? This MAE has a large value, that is 82,288. Now if you compare it with the price we have, so if I just scroll up, the price we have is in millions, right? The price we have is in millions. So 1 into 10 to the power 6, or 1.05 into 10 to the power 6, and with that, in respect of that, we have 82,000. So we have price in crores, right? Crores or lakhs, okay. Let's say 10 lakhs or 50 lakhs or 60 lakhs or something like that, and in respect of that we have a 82,000 average error. So not very good, but acceptable in the form of, you can see, you can still pretty accurately consider it. We can always improve our predictions by doing some analysis or featured engineering, but for the sake of time I am not doing that. Let's see MSE. What does our MSE says? So I will just copy it. And just test it here. So in case of absolute error, we will try mean. Mean squared error, and also we will see print. We will use numpy and do the square root, sqrt, square root of this. Okay, and let's just write down RMS. Right? So let's just, so these are my MSE, RMSE and mean average error. Okay, so as you can see, this is not a very good regression model, but still pretty much we can assume, we can have the idea of how the model can be generated and can be fitted and see what are the evaluation performances of the model, right? So this is what linear regression model is. And one other thing I just forgot to mention, this intercept, LR dot intercept, it is nothing but the constant value, right? So y equals to ax1 plus bx2 plus c, that constant thing is that intercept. Okay, and that a, b are these values, coefficients. Okay, so coefficients and constant. Okay, so I hope you got every point of this. Now at this point I will switch over to our chat box and see if there is any query. So I am open to the query. If you have any query, you can ask it. I will give you 5 minutes. So let me also just have some water in between. You have any queries, you can ask me now. Okay, you don't have any queries. Okay, you don't have any queries. Okay, you don't have any queries. Seems like yeah, so we should move ahead. So now that we are done with linear regression, let's go ahead and talk about logistic regression now. Okay, so let me just again switch to my open board. Now, logistic regression is a thing that is used for sorry, not a thing. Logistic regression is an algorithm we use for classification. Okay, so the last task we had regression. Now we have classification. So the classification is if you have okay, if you need some statistical background or mathematical formulas behind classification and logistic regression, you can go to the same book, Introduction to Statistical Learning. Okay, the chapter is I guess 4th. Okay, you can go and check out. For the timing, I will just give you a brief idea of what statistical learning is. What linear logistic regression is. It is a classification problem. So in classification, we have two types of classification. One is binary, one is multi-class. Binary is like whether a person or whether a gender is male or female, right? So male, female, whether some person has got disease or not, yes or no, right? Like that. And multi-class classification, whether an animal is dog or cat or horse or cow or something else. So there are more than two classes present in the target variable. So in the data, our target variable y can have only 0, 1, that is male, female, yes, no, or something else, or it can have more than one, 0, 1, 2, 3, 4, 5. Okay, so depending on the number of levels, the classification can be treated as binary classification or multi-class classification. Okay, so for the simplicity, we will be talking about binary classification, and we can scale it to multi-class classification after we have an understanding of binary classification. Okay, so before we start the classification, there is a very important concept of understanding of sigmoid function, right? So I will try to explain it with the help of our example. So let's say there is a person, and with some symptoms the person came to the hospital, and some test has been done, okay, and the result will be whether the person has cancer or not. Okay, so this is the case. So this is the binary classification. The target is yes or no, has or hasn't, the person have or haven't. So in that case, n number of persons are being tested before. Okay, so and the output of the person, whether 0 or 1, whether they have or whether they haven't, depending on the situation. So there are, let's say, certain amount of persons using those variables x, and certain amount of person who have cancer, right? So now if I want to draw a regression, the regression line will be something like this, try to fit. And if I go by this regression line and try to predict whether this person X, Mr. X, has the cancer or not, it may give even negative. Okay, it can give anything between -infinity to infinity. The result, the output numerical value can have any of the value from -infinity to infinity, depending on where it is plotted on that curve. So it makes no sense, right? So to avoid this thing, what we do, we introduce a sigmoid curve. Okay, so this is our linear regression, so which it takes y equals to, let's say, ax plus b. So this is our linear expression curve. Now what I want to do, I want to create a sigmoid curve using that, and the sigmoid curve is it takes any input and convert it and gives output between 0 to 1. So this is the operation of sigmoid curve. It takes any number and convert it into 0 to 1. And what is the expression for it? So theta z, phi z is equals to 1 upon 1 plus e to the power minus z. Okay, so this is the expression of sigmoid curve, and z is the expression here. So if I pass it here, so it will turns out 1 plus e to the power e to the power minus x plus ax plus b. Okay, so I guess this is visible. So this is how it is converted, right? Now once we have this, so this curve here, that is 0 and 1. Let me just zoom in again. This curve, what has like this, it now will be converted into something like this. So this is my phi z of this variable. Okay, so any problem, any given value or any given sample will be converted into a sigmoid function. And now we set a threshold. Generally we set 0.5. If the value is less than 0.5, we use it as 0. If the value is greater than 0.5, we use it as 1. So if we have any values between 0 to 1, and depending on what is the if it is greater than the threshold, it will be considered as some class, and if it is below the threshold, it will be considered as another class. So this is the whole concept of logistic regression. So the probability, it calculates the probability. If the probability is 0.5, p less than 0.5, the class is equals to 0. If p greater than 0.5, the class is 1. So this is how it assumes or separates the class. Okay, so now this is being discussed. Let's just jump into the code. I guess this is clear. Let me just switch my window. Okay, just a second. Yeah, so let me just open another Jupyter notebook and let's just new notebook. Okay, now what we will be doing, we will be doing logistic regression. Okay, so let's just take our data for logistic regression. I have chosen this Titanic data, right? So this is a famous data. If you go to Google and type Titanic dataset, Titanic data CSV, you can even get the CSV file directly, or you can go to Kaggle and download it. Okay, so I have already downloaded and imported it. Okay, so let's just import the data. Before that, before importing the data, I need to import the libraries, right? Import pandas. So let me just copy it. It will be faster. So let's just run that. So our libraries are imported. Then let's just call the data as train. That is our training data, pd.read CSV. And let's just call the data, which is our data. What the data is already split into training and testing, right? So I'm taking that training data, just run. So let's just see how the data looks like, and let me tell you what we will do with the data. So the data consists of passenger, survived, 0, 1, 0 means didn't survive, 1 means survived, the passenger class, the name, the sex, age, siblings, whether the data had the person had siblings or not, perch, the parent, whether the data with their parent or not, 1, 0, the ticket number, the fare, the cabin, and embarked. Embarked means where they boarded from. Okay, so S means Southampton, S means Southampton, Q means Queensburg, and there is another C. There are 3 embarked, so the C means somewhere else. Okay, so some other places from where the passengers were boarded or started their journey. So this is the entire data set. Let's just look into the train.info so that we can see the info of the data. So these are the data. So you see there are some integers, some objects, the namesakes we can understand from the column itself. It will be a string. Then age is float, sibling and parents will be integers, ticket is again float, fare is in float, cabin and embarked. Okay, object. So now let's as you see here, there is something called NaN, that is missing values. So there has been some missing values in some of the columns. So let's just find out what are the missing values. Or train dot, how to see that? Train dot is null. So if there is a null value or not. So it gives a Boolean result. So here you can see if it is null, it will give true, so that here we have a null value, and if it is not null, it will give false. So these are the values we have, these are the values we don't have. Okay, so let's just try and plot it, visualize it. How we will do that? Let's just do is in a heat map, SNS dot heat map. Okay, and pass on this thing, this argument. So it will have a heat map, and we don't need any levels. So y levels, sorry, y tick levels, let's say is equals to false, false with capital F, C bar is equals to false, and C map is equals to so y column, we don't need any y column, so that is why I wrote tick level. So these are the ticks, we don't need that. We do just by this thing we can see count C bar, so there will be no variation of colors. If there is true, there is true, there is false, there is false, and varieties is the color map, the palette we are using. So I encourage you to go to the syntax and try to find out how many arguments and how to pass those arguments. Okay, so I'm just giving you by examples, by means of the use in this case, particular cases, so, but you can use it in various ways. So you just try to find it out, what are the arguments and how to use it. Okay, so for the time being, we can see here age has some missing values and k-bin has some missing value. So k-bin has a lot of missing value. So how to deal with this missing value? We can probably drop this column, because so many missing values is there, this is of no use, right? So we can do that. So first we will do dropping. Okay, so let's just set the style, SNS dot style, sorry, set style is equals to white grid. Okay, we will deal with these missing values. First let's just see how many. So what we will do, we will just try to see who survived the crash, the accident, and who didn't survive. Okay, based on the given data, right? So that is our aim, the classifying who survived or who didn't, right? So let's just see our class, the target class, target variable, and how the target variable is distributed. So for that, let's check count plot, and x is equals to our survived, and data is our train. So if I just plot it, so you can see 0 means didn't survive, 1 means survive. So these many people didn't survive, more than 500 people, and around more than just above 300 people survived. So these many people died, these many people survived, right? So this is the distribution of our target variable, right? A little bit of imbalance data, but it's okay. We don't need to do a variety of tasks for that. So let's just see out of those who died or survived, how many of them are male and how many of them are female. Okay, So we have, for that we have a sex column. This is our sex column, right? So we can use that information. So use it. Let's use its counter plot, sorry, count plot, and let me just copy the syntax here, pass it here, and let's just use hue is equals to sex. As you can see, so the person who died most of them are male, very few of them are female, and the person who survived, most of them are female, very few are male. Why that happened? Because it is said that most of the female were rescued first, then the female and the children, and then the male passengers were taken out of the Titanic. So this is what we heard, we knew, and the data says the same thing. Okay, so the number of female died is very less as compared to the male passengers. Okay, so this is another understanding we can derive, just very basic exploration of the data, right? So let's just go ahead and see some other classes, or see some other hues, and let's see how we can see something meaningful there also. What you can do, we can do the survived versus some other hues, right? Let's just take this and copy paste it. Okay, and in case of sex, let's just pass passenger class. Okay, so passenger class means which first class, second class, or third class ticket a passenger has purchased. So as you can see, the third class where the most number of third class passengers died, because if you see, you can find the distribution of the classes. The third class passengers were, the seats or the cabins of third class passenger were below, downside of the ship, was in the downside of the ship, and the first class passengers were the top side of the ship. Okay, so once the ship was drowning, it is expected to that the third class passengers couldn't survive. They were the first who took the hit. Okay, and that is the case of survival and not survival for passenger class. Okay, we can do it for other features also, but let's just do some other exploration, like SNS.distribution plot. So this plot is equals to, we can find, let's just pass the age column. What is the distribution of age? We will do drop in a, if there is a nan value, then it will show some error, so we will drop that nan value. KD is equals to false. I encourage you to find what are these things, and bins is equals to, let's say, 30. Okay, it shows age, there is no column as age. Let's see, it is a capital A. Okay, so the bins means the entire range of the age is grouped into 30 groups. Okay, so there is a group from 0 to certain amount of people, 0 to 5, let's say, then 5 to 10, and like that. Okay, so up to 80, up to age of 80 passengers were there, and this is the distribution. A lot of infants were there, and the majority of age is like 25 or maybe 30, 31, like that. Okay, so this is the distribution of age. What number of age people were present in that ship. Okay, you can vary these bins and see how it affects Okay, so if I take 10, what is the, so this is the performance, this is the distribution, like where. Okay, so now let's just let's do some other something else. So SNS dot, let's see the count, let's see the count of sibling. So how many people were with their siblings? So for siblings it is SI sib SP, I guess, if I remember it right. Let's just see train dot columns. Yeah, I wrote it right, I guess. Yeah, sibling dot SIBSP, and pass the data as train. So let's see the count plot. What happened? SIBSP, okay, capital S. So very few number of people were with their siblings. Okay, you can see whether they were with their parents or something or like that. Okay, so now let's just see some more stuff. Let's see what are the fair distribution. Okay, so you can see the distribution using the pandas also. So how do we do that? So we call the column like fair, and we just call hist, which stands for histogram. If I just plot it, not again this capital H. So this is a pandas plot. Okay, so this is the distribution. The most number of fare of the ticket fare were very few, very little. Okay, so this is a dollar, so it is $0 to $50, between $0 to $50, right? Most of the fare. So if I want to see in more distributed form, so we can do that also. So let's just bins equals to, let's say 40. If I just run it, so this is the distribution. If I just make the adjust a figure, you can see it more clearly. Fixed size, let's just 10,4. Oh, I forgot to give you. Yeah, so as you can see, most number of the tickets were between only 0 to let's say 20 bucks or $20, right? So most number of people were expected, or most number of people were like third class, purchase the third class ticket. Okay, so this is the conclusion we can see here from this distribution. We can do some other things also, but further exploration I will leave it to you. Let's just jump into the data and do our analysis, or do our training part, because we are really running out of time. Okay, so before that, we just somewhere someone said the box plot, how the box plot shows. So this is a good data to show box plot. So let me just show the box plot, and let's pass some variables as, let's say, the P class, so the passenger class, and the age. And the data is train. Let's see. So this is the box plot. This is how box plot looks like. So we have 3 different classes, and we have a variation of ages between those classes. So the first class passengers are more into their 30s and 40s. The second class passengers are more into their 25 to 35 of age, and the third class passenger are in less in age, so they are more eligible, or more they couldn't afford. So that is very significant, or very common, or very predictable, right? In your earlier age, you cannot afford to do first class journeys if only you don't have your parental money, right? On your own you cannot do that. Okay, although there are some outliers, these are the outliers. So these are the people, instead of being third class, they had some other class. They had they were at age of 50 or 70. So although they got old, they couldn't afford other classes. So this is the meaning of box plot. Okay, so I thought it would be better to show you. Now let's just jump into the data cleaning part. Now we will be cleaning the data. So as we showed it here, we have some missing value at age and cabin, right? So let's just clean those missing values. So let's just define a function for age. Impute age, and we will take a value. So what we will do in case of age, as we have few number of missing value, we will replace it using some other values. So what will be the other values? So other values will be something that we will decide what we will be doing. So the age distribution, as we can see, where is the age distribution? Age. This is our age distribution. So most of them are from 20 to 40, right? So we will just and from here also we can see 20 to 40, and from here also we can see if the person is in first class, then the age is between this, the average age is this. If it is in second class, the average is this. If the person is in third class, the average is this. So we can use this information also, or we can just directly use the average age of overall average age. So whatever you think may be suitable, you can do that. But in my view, if I do furthermore classification using the class-wise classification, we can have more subtle age or more subtle imputation, or replacing the missing value. So what I will do, I will take a condition that if the person whose age is missing is from first class, I will replace the missing value with this value. So this is near about 38 or 37. Okay, and similarly, if it is from second class, the age will be 29, and if it is for third class, the age will be 24, around 24, right? So let's just create the function. So let's just age is equals to C0 and and P class, passenger class, is equals to C1. So we will pass a list. In that list we will have, the first thing will be the age, and the second thing will be the class. So the function will fetch these two things from the data. It will fetch the age and the class. Where is the class? The P class. This is the P class, and we know that there is no missing value in P class. So we will take age and P class as a list, and then we will do some certain operation. Okay, so what we will do, if PD dot is null, what is null? Age. If age, this value is null value, then what it will do, it will then check if P class is equals to 1. If it is first class, then it will return, let's say 37. The age will return 37. If the P class, if the P class is equals to 2, the second class, what it will return? It will return, let's say 29, and else it will return 24, right? So this is our case for if the age is null. And if the age is not null, in that case, if the age is not null, else it will return? It will return the age. It will return the age. Okay, so fairly simple function to understand. So I guess you get the idea. If it will fetch the age and passenger class. If the age is null, then it will return some values depending on the passenger class, and if the age is not null, it will return the age itself, right? Oh, sorry, return age, my mistake, right? Okay, so let's just run it. So we have our function ready, so let's just run our function through our actual data. So what we will do train. We'll create a function, create a list, and that list will contain age and sorry again, I'm making the same mistake, age and t class. These are the two columns. Okay, so I have that list now, and I will just do apply. What I will apply our function. Now we don't need lambda function. We have made the function because it cannot be used in lambda function, or if you try to do it, it will be very, very complex. So we made the function and we apply the function. So what is the function? Impute age, and we will use axis 1, that is column wise. Now this will replace our age wherever the age is null, and now where that function, when the function is ran, we will want to try to replace our existing age column with that. So existing age column is equals to this thing. Now if I run this, and now if I take the heat map, sns dot heat map, and pass train, the same thing. Okay, so let me just copy this from here. Let's just try to see if what are the null values now after this function, right? So let's just you see there is no age, that is null value, right? So the cabin has a lot of null value, so we don't want to replace it. We will just drop it. Okay, so to do that, train dot drop, and we pass the column name, that is cabin, with a capital C, and pass the column name axis equals to 1, and then in place is equals to true. Okay, and then again let's just see if that works or not. Let's just do that plotting again. Yeah, okay, so we have a single null value here also, so we will just now we will deal with that also. So we have dropped the column, we cannot see the column anymore, and now there is a single column. So instead of replacing it, we will just drop it. Okay, so train dot drop na. Okay, now if after that, if I just plot the diagram again, let's just do that, and just run that. So now you see we don't have any more null value. So we dropped the NA, and the resulting output we stored as train. So now the data is free from missing values. Okay, now another thing we have is categorical data, right? So if I just train dot head, so there are some categorical data, sex and name and all those things. So let's just first drop this irrelevant column that we don't need. Okay, so let's just train dot drop okay, let's just treat sex as our first thing first. So let's just convert this sex column from male female to something readable for the system. So to do that, we will do dot get dummies. So pd dot get dummies, what it will do, it will replace the existing string with a dummy variable. Okay, so for male it will be say 0, or female it will be 1, like that. Okay, so where it will use the dummy, so train and the column is sex, right? So and we will use that as our okay. Let me just do that and then I will explain. Get dummies, drop first is equals to true. Okay, so we have, if I just let me just okay. So if you can see, sex is replaced, the male and female is replaced by zeros and 1, and drop first is equals to true means the first one will be dropped. So if I don't use drop true, let's just see what happens. It will keep the first column also. So what is it is saying, for 0 for male and for female, it is replacing the both. Okay, so there are two categories, male and female. For both they are using the dummy category. So for male if it is 1, female it will be 0. For if female is equals to 0, male it will be 1. So we don't need, if I know it is 1, the other one will be obviously 0. So we don't need the first one. So that is why the drop first will be, that is why we use drop 1 is equals to 2. We can use single variable to represent two variables, right? Two categories, 0 and 1. Okay, and same we can do for embarked. So embarked is embarked, this embarked. So let's just train embarked. So let's say embarked. Okay, if I use embark, so this is another thing. So Q, S and C, so we dropped C because we know if it is 0 and 1, other will be 0. If it is 0, 0, other will be 1. So that is why we dropped that one also. So this is how we can replace the categorical variable or the string variable into the numeric variable. Okay, there are other ways also, like using one-hot encoding, but this is actually one-hot encoding. To do that one-hot encoding, you have pd.getDummies method. Okay, so now as we done doing that, but using this won't be anything. So what we will do, we will drop some unnecessary columns. Okay, so let's just drop all the columns that we don't need, or we will not use it here. You can use that. For that, let's just copy the dot column. Let's just print the column first. Okay, from here we will just do some dropping. So sex we don't need, because we will be replacing sex with something else, right? The dummies. Okay, then we don't need embarked, because we will be use embarked, the dummy variable of embark, right? Then we don't need the name. We won't be using that thing for our purpose right now. We don't need the ticket. The ticket number won't matter for this classification. And okay, so this much will work. And then maybe the dropping will be done axis 1, that is the column wise drop. We will drop the entire column, and in place is equals to true. So we have in place equals to true. That means we will be keeping it forever. So what is the error? A value is trying to be sent on a copy of a slice. So this is a warning. Don't worry about the warning. So train.drop, so in place equals to true. We got that. So let's just see the train.head now. So these are the this is the train. Now that is our final thing. So we have dropped everything. Now let's just we can also use that age now, concatenate. So let's just concat the other thing we just derived from sex and embark. So just use that here. Train is equals to pd.concat. So concat is a method to concatenate separate things. So we concat it like train comma sex comma embark. So train is the main thing, the main data frame we have right now. This is the train, and with that we want to concat sex and embark. So let's just run it. Sex is not defined. Okay, that is a capital S. Sorry for that. Okay, now let's just see what is train.head looks like. So as you can see, it is concatenated. Oh, sorry, I forgot. I need to mention the axis also. Let's just do it here only. Let me just concatenate it first. Okay. Why it is showing error? Why it is showing error? Drop in a. Did I do drop in here? Concatenate sex and embark, drop true first. So let's just run that. Let me just missing value. These are the visualization we don't need now. Let's just mm, mm, mm. Yeah, so that is concatenated. So maybe there is some issues because I dropped some values row wise and then concatenated, so the number of rows got different from the actual values. So now that we have, so now we don't need this now. So let's try building the model. And now we are done with the data cleaning part. Just a second. Yeah, so just let's build the model x. For x we will be doing that train drop, and we will drop the column, the target column, that is our survived, and it will be column wise dropping. So that is the rest of the column we already did. Why it is showing Q&A? Yeah, so survived train dot drop NA. Train dot drop. Okay, so we dropped the survived column because it is our target column. So y will be our target column, that is train. Our target column is the survived, right? So we have our training and testing. Now we will do the from sklearn. Let me just do it in a from sklearn. What we will be doing, we will be calling the train test split, right? Okay, then we will do the same thing, training and testing splitting. So we will call x train x test, y train y test. So in that train test split we will be dropping train, from train we will be dropping x axis. So here we will do like x and y, x comma y, right? So let's just do that. So let's just do the train test split. Then after we split the thing, we will be doing the training and testing, right? So we just call up logistic regression, that is in linear model. Another thing, from that now we will call an instance, that is our, let's say, a logistic regression model, named as log model. Let's call it, we can call it by your name, anything you wish. So let's just call that instance, that is our logistic regression, and let's just fit it into x train and y train. This part are simple and repetitive, right? Like we did in linear regression. So we will, there is a string value. Where is the string value? Why it is still okay? We just forgot to drop the cabin column here. Okay, so let's just drop the cabin column. Just a second. Yeah, so we will drop the cabin column also. Okay, sorry, the cabin is in capital. We can just do it here. Here from the before testing, let's just add another train before drop. Here we can add, right, from here. Let's just add train is equals to train dot drop cabin, and x is equals to 1. Okay, then the train test split and all that stuff. Don't worry about this warning. Okay, logistic regression, yeah, we fitted the model, and now we will be performing the prediction. So the prediction will be log model dot predict x test. Now after we do that, we will import some evaluation metrics. If you remember, the confusion matrix is our evaluation for our classification problems. Okay, so for classification, we will import scikit-learn.matrix and classification report, and we can see what are the classification report, what are the classification performance our model has done. So to do that, we will just go and print the classification report and y test, that is our actual value, and the predicted value as predictions. And if I just run that, you see these are the overall classification values. So this is our precision, recall, the accuracy 0.80, so 80%, our model is 80% accurate in this classification problem. So I wish you can also do that from let's just import some more evaluation matrices. So to instead of classification report, you can just import classification matrix. Okay, and sorry, my mistake, confusion matrix. And using that confusion matrix, you can plot the confusion matrix also. So confusion matrix, and you just pass the prediction true value, y test, and predictions, and let's just So this is our confusion matrix. Out of all the input test values, 13 and 36, these are the true positive and true negative, and these are the type 1 and type 2 errors. So this is our confusion matrix. This is our accuracy. The model is 80% accurate, which is not pretty good, great, but acceptable. If you go to Kaggle and find out, there are a lot of models doing very good job, like 92, 93 and 95% of accuracy also. But for the learning purpose, I guess this you understood the concept. And now I would like to take any question, although I already surpasses the time, but I don't think KNN we can cover in this thing, because it will take another 1 hour. So instead of doing more thing in less time, let's just ask if you have any questions, or we can go ahead and give you some information about what will happen from now on. So any question you have? Anyone having any question can ask. Please ask, so that I can understand whether there is any confusion or not. Okay, if there is no question, probably there can be two reasons. One thing, you understand everything, which is too good to believe, or the sessions are very overwhelming that it is a lot to take. So in any case, I would like you to go through some of the problems. So what I will do, I will share the codings that we done in 3 days, not 3 days, last 2 days, today and yesterday, and I will give you one linear regression and one logistic regression problem also, so you can try it on your home. So go through this process. You first go through the coursework we have done, the codings of the coursework we have done, try to understand that, and after that you go to the problem statement. And the problem statement is designed so you don't need to wonder about what you need to do with the data. The instructions were given, instructions are given, you just need to write the code to execute those instructions. Okay, so I will share with you the .ip and .yv code files the exercise files. 2 exercises will be there. You need to build 2 models. One is logistic regression and one other is linear regression. Okay, and after 1 week, I expect you to do it in 1 week. I will provide you, you submit the, so let me just tell you how you do that. So you go to your home page. If you are using Anaconda, you launch the Jupyter, you go to Python new, okay, new Jupyter notebook, and here you will be uploading, you download the IPNYV file I share with you. Then what you do, you go here, upload it. So once you do upload, you will find your data wherever you downloaded it, you upload it here, okay, and then you will find it here, somewhere here down. Okay, so you open that file. Let's say this is the file, so you open that file, okay, and you here in that untitled one, you just type your name, okay, so that I can understand who done this thing, like that, Snehashish, and then underscore which one is it. So logistic regression, so LR, logar, so my name logar, and just rename it. Okay, and then you just, after doing all those stuff, all the instruction, if you if you perform all the stuff, then you go to file, download as, and you can see here notebook.ipnyb file. So you download it as ipnyb file, save and download it, and then you mail back to me. Okay, and regarding data and all those things, I will be providing you, or I will providing it to you, or Srijit or Chik. So they will provide you that. So we will discuss on that with them. So how to give you the data and the file, and I expect you to submit those two assignments or practice sets by next week, right? So it is Sunday today. By Saturday, I expect you to do that. Okay. If you find any problem, you can always reach Orchik or Srijit, and they will say, or if you want to see, if you want to find me, that is my email ID is snehashish.edu. So I am writing it on the chat box. So this is my email ID. If you want, you can always send any queries regarding those exercises to me. Okay, so I expect you you will be having those assignments, problems and resources datas by tonight or tomorrow morning. Okay, and I expect you to solve those. Okay, so if you don't have any questions, maybe we can close this workshop for today. Okay, I guess there is no question. So thank you for joining. I hope you learned the basics of data science and artificial intelligence and machine learning. And I hope to see you in the advanced workshop also. And meanwhile, you do the assignments so that you get a grip of the basic two examples of linear regression and logistic regression. And I also encourage you to find some other machine learning models also by yourself, and otherwise we will be discussing the advanced or more models in our advanced topics. Okay, so thank you. Yeah, Priyanka, you will get your certificates, but I encourage you to do the assignments first, the practice first. The more you practice, that is, let me tell you a truth, the certificates won't find you a job. Okay, that in order to get a good data scientist role or a machine learning job, you need to have some skills, right? You need to showcase some projects to the recruiter, or maybe some live deployed apps, web apps, like that. Okay, so don't worry about certificates, you will get it, but more importantly, you practice the things. The more you practice, the more you know. Okay, yes, you will get the certificates, no doubt about that, but let's just have that conversation about this learning, right? You will get it, don't worry. Any other confusion? Okay, so thank you. I guess there is no other question. I will wrap it up, call it an end. See you in next week, and hopefully you will get your certificates and I will get the exercise back, so that I can understand what is your understanding from this workshop, and see you in the advanced course. Thank you.